Hi guys, today we're going to be reviewing radicals and simplifying radicals. Although this unit has been taught already this year, I wanted to make sure that we were solid on this concept so that when we got to simplifying radicals with trig, we were able to do so. So we're going to start with example number 1 on your sheet, and it's radical 50. So remember that when we simplify a radical, we always want to break it down. So we can think of two numbers that multiply to 50. I'm going to go with 5 and 10. You can choose two other numbers. You'll get the same answer as me when you're finished breaking it down. Then we see, can we continue breaking down? Well, the 5 we can't, but the 10 I can break down into 5 and 2. So now I want to look to see, do I have pairs? And in this case, I do. I have a pair of 5s. So I circle them together. And remember that pairs are like friends. When you have a friend, you can go out of the house. So 5 is going to go on the outside of my radical. And then on the inside of my radical is what's left over, anything that doesn't have a pair. And in this case, the only number that does not have a pair, we already used the 10, remember, to break the 5 and the 2 down. The only number that doesn't have a pair is the number 2. So the 2 is going to go inside of my radical. And that's it, guys. That's my final answer, is 5 radical 2. Okay? Let's try example number 2. We're going to break down 72. So when I think of 72, my mind goes to 9 and 8. Yours may think differently. Again, you should end up with the same answer no matter what after you break it all down. So 9 splits into 3 and 3, and then I like to get rid of that 9 because it's already broken down. 8 we can split into 2 and 4, and then get rid of the 8 because we broke it down. And then 4 we can split up again into 2 and 2, and I'll get rid of that 4. Getting rid of those numbers is just going to help you at the end to be able to see your pairs a little bit more clearly. So this time I have a pair of 3s, and I also have a pair of 2s. So remember that numbers that have pairs can go on the outside of the radical. So when we have a 3 and a 2 together, we're going to multiply them. So I'm going to write that out so you remember that. Anytime we have two numbers that are outside together, they multiply to make a 6. One pair of 3s and one pair of 2s gives me a 6. And then inside of my radical goes the number that's all alone, or any numbers that are all alone. And in this case, it's the number 2. So 2 is going to go in my radical, and that's my answer, 6 radical 2. Okay, let's move on to problem number 3. We have the square root of 60. So 60, I'm going to break it down with a 6 and a 10. And then you can break down 6 into the numbers 2 and 3. Remember to get rid of that 6 as you go. And then 10 you can break down into 2 and 5. And then I'll get rid of that 10 as we go. So my pairs in this case, even though they're not next to each other, they're still two 2's. So those guys are going to go on the outside of my radical because they're the pair. And then this time there are two numbers that are alone, that don't have anything. There's the 3 and there's the 5. And just like we did in the last example, if we ever have two numbers that are on the outside or two numbers that belong on the inside, we always multiply these together when we put them back where they belong. So the 3 times the 5 is going to give me a 15, and that's my answer, 2 radical 15. Okay. The last example for radicals that I'm going to do with you is radical 35. So breaking down 35, I think about 7 times 5 gives me 35. But I can't break down 7 anymore, and I can't break down 5 anymore. In this case, guys, there are no pairs, right? There's nothing that I can take outside of my radicals. If there are no pairs, that means that those numbers, they both multiply together and go inside the radical. So because I cannot break down radical 35 is actually my answer in this case. Okay, it looks kind of weird because you're just giving back exactly what we had as our problem, but because we cannot break it down, radical 35 is as simplified as this example is going to get. So what I want you to do is, using examples 1 through 4, please try examples 5 through 12 on that first page. Careful with number 9, because 81 you do not have to break down. Think about it as a perfect square. And when you're ready, when you're finished with example number 12, come back to the video to go over example number 13 together. So example 13 is called rationalizing the denominator. We did do this earlier in the year, but I wanted to again do a refresh. That way when we see it later on in trigonometry, we're able to do it with ease. So when we rationalize a denominator, there's a couple things we have to do. We're going to start with example number 13. Example 13, you may remember that when we rationalize, we want to multiply the top and the bottom of our denominator by the same number. So because there's a radical 2 in the denominator, that's what we're going to multiply the top and the bottom of my fraction by, whatever number is in the bottom of the radical. So because it's a 2, we used radical 2. Okay, now we have to multiply across. So when I multiply the 3 times the radical 2, they just glue themselves next to each other. 3 radical 2, they kind of just stick together. But when I have radical 2 times radical 2, that gives me a radical 4 altogether. 2 times 2 gives me 4 underneath the radical. Then you might be thinking to yourself that there's something special about this radical 4, and I always like to put a heart next to it because that heart represents that radical 4 is actually a perfect square. So I can take the square root of 4, which I know is really just the number 2, and on top I'm going to leave 3 radical 2 as it is. And right there, guys, that is my final answer. 3 radical 2 all over 2. Just remember that you have to take that radical and actually take the square root of it to get your final answer. So in this case, number 13, there were only 3 steps here. It's pretty simple. Hopefully you remember some of those steps from when we did rationalizing earlier this year. Let's try example number 14. So this time we're going to multiply the top and the bottom of my fraction by a radical 3, because 3 is the number that's in my denominator this time. Okay, our next step is we have to actually multiply across. So on the top of my fraction bar, I'm just going to glue the 15 and the radical 3 together. So I get 15 radical 3. And on the bottom, radical 3 times radical 3 is radical 9. Again, once we get to this step, you will always get a perfect square. So that's something to look out for. If you don't get a perfect square, you're doing something wrong. So radical 9 is a perfect square because the square root of 9 is just the number 3. And on top, we have 15 radical 3. So again, we had to take the radical 9 and change it into a 3. Now, there is one more step here, so I'm going to take this and move it down here so we can do it together, because you might notice in this example that we have 15 on top and we have 3 on the bottom. And 15 is divisible by 3. When I take 15 and divide it by 3, I actually get the number 5. But that radical 3 did not change. It's still there in my final answer. So that's just simplifying if we can. If there are 2 numbers on the top and the bottom that can be divided outside of the radical, we need to do that first. So 5 radical 3 here is my final answer for number 14. One last one that I want to do together is example number 15. And this example is a little bit harder, you may notice, because we have a number in front of the radical in the bottom of the fraction this time. But we're going to start by doing the same steps. We're going to look to see what is the radical in the denominator, and that's what we're going to multiply by on the top and the bottom. So radical 7 on both of them. Notice we did not bring the 2 with us, only the 7 on the top and the bottom. So now we have to multiply across, just like we did in the last two examples. So on top, we glue them next to each other, and it just becomes 10 radical 7. On the bottom, the 2 is going to come out front. We're just going to keep it there. And radical 7 times radical 7 is radical 49. So the 2 does not change, it just kind of scoots on over, but the 7 times the 7 becomes a 49. Okay, so that 2 just drags along for the ride. Now we notice every single time in step number 2 that 49 is a perfect square. So let's go ahead and take the perfect square. 10 radical 7 is going to stay on top. We're not changing it. The 2 is going to come along for the ride. But the square root of 49 is just the number 7. So that's where my perfect square changed into the number 7. And then I can go ahead and multiply those two numbers on the bottom. So I have 10 radical 7 on top over 2 times 7, which is just 14. And then the last step, just like we did before in example 14, we want to see, can these two numbers be divided? Well, 10 and 14 are not divisible, but 2 goes into both of them. So when I take 10 and I divide it by 2, I get, let me make that division symbol a little bit bigger. 10 divided by 2 is 5. Remember that you keep the radical 7. And then on the bottom, I can divide 14 by 2 as well, and I get 7 on the bottom. And this is as simplified as it gets. So all we did was we took the 10 and the 14, and we just simplified it. Again, you can't divide them, but 2 goes into both of them evenly. So 5 radical 7 is your final answer. Okay, I want you guys to try examples number 16 to 20. So now you try 16 all the way up to 20. And again, if you have any questions as you're going through this, feel free to stop by my office hours today and ask any questions you may have, all right? I'm looking for all work shown just like they were done in all of these examples today. Thanks, guys.